Hello everyone, today we'll be looking at several ways to deploy VM in Azure, like from Azure CLI, Ansible, Terraform and more. All the resources and links that I used in this video will be provided in the description, and the commands and the files that are used to create the VM will be uploaded on my GitHub repo. Now let's get on to the first demo. So first of all, log into your Azure account. Make sure that your account has the proper permissions to create a VM. For this demo, to keep it simple, I have created an account with the owner permissions. To create a VM, click on the virtual machines here or search for virtual machines in the search bar. Click on the virtual machines. Now click on create and click on Azure virtual machine. So first of all, select the subscription that you want. I am having only one subscription, so I'll leave as it is. Next is to create a resource group. This is where all the resources that are associated to this VM will reside. For this, I will create a new resource group. So click on create new and give a name for the resource group. I'll give it portal-rg. Click on OK. Now that the resource group is created, let's give a name for the virtual machine, portal-vm. I'll choose the region that is closest to me. We can leave the rest as it is. Now to select the image, I'll go with the Ubuntu 2204 LTS version and I'll keep the size to a minimum, so that we can reduce this cost associated with this demo. So click on all sizes. I'll search for B1S. So this is the lowest that you can get, and you can easily do a demo inside this machine. So I'll go with the SSH public key since it is a safer option. Sometimes I will be using password to keep it simple, maybe in one of the next demos. So I'll keep the username as Azure user. So we'll use the already existing public key. So I'll copy my public key from my machine. Go to .ssh folder. If you do not see IDRSA files here, use this command ssh-keygen and press enter. Since I have created the files here, I'll stop with this. So we have to copy the contents of the IDRSA.pub file. So this is the content of that file. I'll copy this and paste it here. I'll minimize this for now. Next, we can set the inbound port rules. We have to leave the SSH port as it is, as we will need to use it to confirm the creation of the VM. Next, we'll go to disks. We can leave the defaults in disk as it is. We don't need to change much anything here. Click on networking. So it will create a new virtual network and a new subnet. Also, we'll create a public IP so that we can connect to it from anywhere. Rest all we can keep as it is. We don't need to see much more in these options since it is a basic demo. So I'll click on review and create. Now you can double check if the options that you are given are correct. So I'll click on create. Now we will have to wait for the VM to get created. We can see the deployment has been succeeded. Now let's go to the resources, get the public IP of the VM and we'll connect to it using our terminal. Click on connect. We'll get the public IP here. Here copy this public IP, go to your terminal and use the following command, that is SSH username, that is Azure user that we provided in the console, and paste the public IP. Click enter. So accept this fingerprint, type yes and enter. As you can see, we have logged into the portal VM. This is the host name that we provided in the Azure console. Let's try to run a simple command here. Sudo apt update. Everything is working fine in this VM as we have created the VM successfully using Azure Portal. Now let's move on to the next demo. Now the next demo will be deploying the VM using Azure CLI. Before we get on to install the Azure CLI, we need to take note of something, that is the tenant ID. For that, go into Entra ID, click on Microsoft Entra ID and copy the tenant ID that is visible here. Copy this string and keep it somewhere in your notepad. Now let's move on to install the Azure CLI. Go on to this URL. I'll provide the links that I use in this video in the description. So once we get to this page, we can see there are various methods, like for Windows, Mac, we will be going with Linux. So if you are using Ubuntu or Debian, you can click on this link. As you can see, there are many options for many distros. So for apt, you can follow these instructions where you can install by using a single script or by the step-by-step instruction, that is to get the GPG key, add the repo and install the Azure CLI. Now I will be using Fedora to install the Azure CLI. So for that I'll use the command sudo dnf install azure -CLI. Provide the sudo password. Since I already downloaded the Azure CLI, it shows that nothing to do and the dependency is resolved. Now let's configure the Azure CLI. Now first we have to log in using the Azure credentials. For that, the first command is az login -tenant, and here paste the tenant ID that we copied earlier. We have to use another switch, that is --use device code, and press enter. So copy the URL that is present on the screen, and also we need to copy the code later. Now let's go on to the browser, paste the link, and now we have to paste the code that we got earlier. Paste the code and click on enter. As we are already logged in another tab, it shows the account. So click on that account and it will ask a question that are you trying to sign into Azure CLI? So click on continue. Now the configuration has been done. So close this tab and go back to terminal. Here you can see the cloud name Azure Cloud and the tenant ID that we pasted earlier and the username that we signed into. Now let's proceed on to creating the VM. So before deploying a VM, if you need to know all the VM sizes that are available in Azure, use the command az with the VM option, that is like this. So we are using az command with VM option, listing all the sizes in the location of central India. So you can change the location as you want, and we'll tell it to produce the output in a table. Press enter. As you can see, there are many sizes here. For now, as usual, we'll be using the lowest size that is available, that is standard B1S. Now the command to create a VM using the Azure CLI is like this. So here we will be using az command with the VM option. We'll use the create. We'll specify the resource group where the VM will be created, name for the VM, and which image we'll be using, that is the ISO or image in case of Azure, that is Ubuntu Server 2204. We'll specify the username and we'll generate SSH keys or use the existing keys if they are already present, and we can create a standard public IP, and also we'll specify the size of the VM, that is standard B1S. This is the lowest size, and we also create a network security group with the rule of allowing SSH so that we can SSH into it to confirm the creation of VM. Now that the command is correct, we'll press enter. As the error message says, we have not created the resource group beforehand. Now let's create the resource group using the command azure group create --name VM test -- location central India. Press enter. Now that the group is created, let's run the previous command. Click on enter. As you can see, the VM is getting created. Okay, now that the VM is created, we can see power status VM running. We also got the public IP address so that we can use it to connect to the VM. Now let's connect to the VM using the command ssh @IP. Press enter. Type yes and enter. Now that we have entered into the VM, to verify that everything is working fine, we use the following demo command, that is sudo apt update. As you can see, everything is working fine. Now that we have also deployed the VM using Azure CLI, let's move on to the next demo. Make sure that you install Azure CLI before moving on to the next demos, as it is a prerequisite for any of the tools that will be running later. Don't forget to remove the VM before proceeding on to the next demo to avoid unnecessary costs. You can simplify the process of removing the VM by removing the resource group altogether, like Azure group delete --name VM test. Press Y and enter to delete the resource group. It will make sure that all the resources inside the resource group, that is a VM and all its component, will be deleted. Now press enter. Now that the command has run successfully, we can verify that the VM is deleted by using the az VM command list -o for output in the table form. As you can see, nothing is written, so we can say that the VM is deleted. Now let's move on to the next demo. Okay, now the next way to deploy the VM will be using Ansible. So for that, we have to take note of another thing, that is a subscription ID of the account. Let's go to the Azure Portal. So search for subscriptions and click on the subscription that you have, or you can copy the subscription ID that is present here and keep it in Notepad somewhere. Now let's proceed on to install Ansible. For that, we have to first install pip. So the command will change slightly depending on the distro that you use. So for Debian or Ubuntu based, use the command sudo apt install python 3 -pip Since I'm using Fedora, I'll be using DNF and press enter the sudo password. After pip is installed, we'll use the pip to install Ansible. Use the command pip install Ansible -- user and press enter. Okay, now we have installed Ansible. We'll verify the installation by checking the version of the Ansible, that is Ansible -- version. As you can see, we are using 2.17.6 Ansible core. Let's go ahead and take the steps to deploy the VM. First, we'll create the resource group that is needed to deploy the VM. We'll use the previous command like Azure group create. We'll give the name as Ansible and the location of Central India. Press enter. The group is created. Next, we have to create a service principal for Ansible. Service principal is a identity that is used by applications rather than a user to communicate to Azure and have certain permissions. So to create a service principal, we have the following command. So you use the Azure AD service principal create. We give the name as Ansible. We'll provide the contributor role and it will be in the scope of subscription, and we have to paste the subscription ID here that we copied earlier. Once you pasted the subscription ID, press enter. So this command will provide some important details that needs to be protected. So make sure you copy that details and keep it safe somewhere else. So the info provided here are app ID, display name, password and tenant. So copy these details. Now we have to create a role assignment for the service principal that we created earlier using this command. Here we have to again replace some stuff, that is subscription ID and the app ID that we got earlier. After we paste the required things, press enter. We will be provided with many details that we don't need for now. Let's clear the screen. Next, we have to create an credentials file under .azure directory. For that, we need some details that we collected earlier. If you want to get them again, we can use the following two commands. So press enter and here we'll get the subscription ID, tenant ID and also the client ID. With this we can create the credentials file. So we have to go now to the home directory, create a hidden directory that is .azure. So use the command mkdir .azure. Since .azure directory is already created, we'll just cd into it. We'll check what are the files that are present here. As you can see, there are some logs and telemetry present here. Now we need to create the credentials file. So create a file name credentials and we have to paste the information that we obtained earlier in this manner. So subscription ID, client ID, secret, that is the password that we got, and the tenant ID. After we paste all the details, save the file and exit out of the file. I have created the credentials file. So there are two options for using the information that we got. One is to create the credentials file that we created just now. Another one is to export all the information as environment variables. You can use whichever suits your purpose. So I'll keep the credentials files as it is. Next, we have to install the AZ collection using the Ansible Galaxy, which is used for Ansible to connect to the Azure and perform the required tasks. For that, we'll use this command. So here we'll be using the Ansible Galaxy collection subcommand to install the azure.az collection. Press enter. The collection was installed successfully. Now let's check if the Ansible is able to connect to Azure by using a demo command, that is creating a resource group. So we use the Ansible command, run it on localhost, and we'll use the module that we installed earlier from the azure.az collection, that is Azure Resource Manager resource group, and we'll provide the parameters, that is name of the resource group and the location. So let me modify it, Central India, and the resource group name as demo.rg. Press enter. Okay, so we can see that we get an error of module not found, that is azure.mgmt network. So to solve this error, we have to first find the interpreter that is being used. In your case, it may be under a pipx directory. It means that the interpreter is under virtual environment. In my case, it's directly user bin python 3. So get the interpreter path, use that. Okay, so before that we have to navigate to a certain directory. Let's go to the home directory. Here you can find an hidden Ansible directory. It is .ansible. Here navigate into collections, Ansible collections, go into Azure AZ collection. Here you can see a requirements.txt file. So this file contains all the requirements that is needed for this collection to function. So we'll make sure that all the modules present in the requirements.txt are installed. So copy the interpreter path that you got earlier. Use the pip module, that is -m pip install -r for specifying the requirements file and specify requirements.txt. Press enter. It will download all the requirements that are needed for the Azure AZ collection to work. If you have any easy solution, please put it in the comment section. Also, it is generally recommended to have Ansible under virtual environment, but I could not make it in this installation. So if you have any way to do that, also put that in the comment section. After all the modules are required installed, let's test the command that we used earlier. Navigate to the home directory and find the previous command. So here we have the previous command. Let's run it. We are not getting any errors for now. Okay, we can see that the resource group has been created successfully. Now we can proceed on to creating the VM. Before that, we'll make a directory for that file to store, mkdir ansible cd into that directory, create a file vm.yaml. We'll paste the YAML that is required. So let me explain the YAML file. So this is the name of the play, that is create Azure VM. We'll run it on localhost and use the module to connect to the Azure. Connection will be local to prevent SSH connection to the same machine. So the first task will be to create a resource group where the VM and all its components will be residing. So we'll use Azure RM resource group module that is present in the collection. We'll provide the name of the resource group and the location. We'll change that to our needs. Next will be the virtual network. Name of the resource group will be the same as we provided earlier. Name of the virtual network VNet and the address. Next we need to add subnet. Next we need to create a public IP address through which we can connect to the instance. So we'll use a static public IP address and we'll make sure to register it into a variable so that we can output the public IP address at the end of the playbook. Next we need to create a network security group with the rule of allowing the SSH. After we have created all the requirements for the virtual network interface card, we proceed on to creating the virtual NIC. For that we have to specify the resource group, name of the NIC, the location, subnet name, virtual network name and the network security group name. Also we need to specify which public IP resource it will use. So we have provided the name of the public IP that we declared earlier. Finally we have to create the VM. So we'll specify the usual details like resource group name and then we proceed to specify the VM size, that is standard B1S. Username that we need to log in, that is Azure user. We disable the password for the SSH and then we provide the public key that is under key data, and also we specify the path where to store this key, that is usually under the .ssh authorized key files, and then we specify the network interface that it will use, and lastly the image, that is Ubuntu server Jamie, and then the other details that are necessary to reference the correct image. Now let's try to run the Ansible playbook. Use the command ansible-playbook and the file name. Now press enter. We can get the public IP from the output that is specified here. So let's copy this and keep it for the later purpose. Now let's wait for the VM to get created. Okay, now the playbook has run successfully. Let's verify that by logging into the VM. So use the command ssh Azure user at the IP, type yes and enter. As you can see, we can log in into the VM. Now let's run a demo command like sudo apt update. So everything is working fine. With this we have also deployed the VM using Ansible. Now let's move on to the next demo. For the next one, we'll be demoing it with Terraform. So let me make a directory for Terraform, cd into the directory. First let's create the main.tf where we'll define the provider details. So open a file name main.tf. So here we specify the required providers, that is HashiCorp Azure RM, that is Azure Resource Manager, and version is 4.9.0. This version may change over the time. Also we need to provide this features block. Since we don't need any particular requirement, we leave it empty. And also we need to specify the subscription ID. We'll provide in the form of a variable that we'll create later. So main.tf is now done. Let's save and exit. Next we'll create the resource group. For that create a file name rg.tf and we'll use the module of Azure Resource Manager resource group and we'll provide a name for this block, that is testing group. So this is only for the purpose of Terraform and not Azure particularly. So this name won't appear anywhere in Azure. So this is the name of the resource group and the location that we provide. These are additional text that is optional. You can keep it if you want to. Now let's save and exit. Now let's create the variables file. So vim variables.tf. So here we declare the variable that we used earlier, Azure subscription ID, and the description is Azure subscription ID and the type would be to string. So we need to create a terraform.tf vars where we'll provide the value for this variable and this variable will be used in the main.tf file. So let's save and exit. Now let's create the terraform.tf vars file. Note that the file name of this particular file, that is where we specify the variables, should be exactly like this, terraform.tf vars, so that the Terraform will automatically load all the variables that is present in this file. So open the file and paste the required values like this. Let's save and exit. Finally we'll create the vm.tf file where we specify all the required configurations for the VM. So vm.tf. Here we start off with creating a virtual network. So name will be Terraform VNet and this name is for Terraform purposes. This is the same for all the resource blocks or all the any type of block that is present in Terraform. So address space will be this, and location will reference it from the resource group location. This is the module that we use to create the resource group, and this is the name of the block, that is testing group, that is specified here in the resource group section, and then dot location to get the exact location from this particular data. And then we use the resource group name. Also we specify that in the same format, except that we provide the name. This type of sentences we'll be using regularly. So next would be subnet. So name will be Terraform subnet. As usual, we specify resource group name and virtual network name. We use this, that is like this one here, and then dot name to specify the exact name, and we provide the prefix of the subnet. Next we create the public IP. So allocation method is static so that it won't change, and we specify the resource group and location using the resource group details. Next we create the network interface card. So as usual, we give the name, location and resource group, and in the IP configuration we provide the necessary details. So private IP would be the internal subnet. We choose the subnet that we created earlier, method of private IP address allocation, and the ID of the public IP address that we created earlier. Next is to create the network security group. So we give the name, and then we give the properties of the security rules, that is to allow SSH, priority is 100, and inbound to allow from all sources, and to allow all destination, and then the destination port. Next we associate the network security group with the subnet. So we provide the subnet ID and also the network security group ID so that it gets associated. And then we finally create the virtual machine. We give the name, resource group, location, and the size of the VM that we used earlier, like in all the methods, the admin username, and then a network interface IDs. You can specify more than one IDs so that that's why it's present in the array. We specify the SSH key. So we use the username, and we specified where to find the public key, and then these are the disk details, and then finally we provide the image that we need to use. So let's save and exit this file. Now we have to initialize the Terraform modules. So for that, use the command terraform init. Now it will download all the modules that are required that we provided in the main.tf file. So Terraform init has been completed. Now we don't need to do Terraform plan since it will be provided in the step of Terraform apply. So use the Terraform apply command to apply all the changes. So now we'll get all the details regarding what will change in the infrastructure. So we can see all the details that will be made. So virtual machine, the plus symbol indicates that all will be added. So nothing will be removed here as of now. So once you check all the details, type yes and enter. So we can make sure that the resources are created successfully by logging into the VM. So I forgot to create the outputs.tf file where we get the public IP. So let's create it right away. So vim outputs.tf. So we get the data using the data block. We use the resource block to create a resource, and we use the data block to get the information about already created resources. So we get the information about public IP, that is the name. We need to provide the name of the public IP that we created. So we use the model name .terraform pip that we specified in this section in the vm.tf file, and then the name, and also the resource group where the public IP is created. And then we output the value, that is data.azure rm public IP .pip output .ip address. So let's save and exit this file. Now let's run it again. Since all the resources are already created, it will stay as it is and also output the value that we needed. As you can see, the only changes are the output that we need. So we'll type yes and press enter. As you can see, the apply is complete and we get the public IP address. So let's verify that the VM is working. So ssh my admin user at press yes and enter. So we'll run a demo command like sudo apt update. So everything is working fine. With this, we have completed the process of deploying the VM using Terraform. Now for the next demo, we'll proceed with the ARM template. that is Azure Resource Manager template. So it is written basically in JSON. So we'll create a file named vm.json and paste the following JSON code. Let's try to understand the JSON. So this is the schema. So this is a standard one. So we don't have to change this much. So there are generally three sections in this file, that is parameters, variables and resources. So parameters, as the name suggests, will be declaring the parameter types and what we'll be needing when running the command using this file. So we need the project name so that we can use that name to generate the resources, and then we need the location where the resources will be created, and then username and the public key. So VM size is already set to standard D2S, so we'll change that to meet our needs. So I'll use standard B1S. I think we can keep rest all as it is. So let's go on exploring the other things. So next is variables. So this is the virtual network name. Okay, so virtual network address prefix, subnet name, subnet prefix, and VM name, public address name, network nickname. Okay, all the network related stuff. Next we'll be creating the resources, that is network security groups, and then we'll obviously specify the rule to allow the SSH. Next is create the public IP address, then we create the virtual networks, and then we create the network interfaces using all the details that we created earlier, and then we specify the allocation method in public and the private IP address just like the previous demos, and then we finally create the virtual machines using all the previous resources that we created, like we provide the public keys on how to get that, where to store the public key that we provide in the command line as a parameter, and then we specify the image that we need to use. So let's save and exit this file. Now we need to specify this file while running the command using the Azure CLI. So I have got the command from the Microsoft official documentation, which I'll link in the description. So this is the command that will run. So it will take every input and assign it the variable. That variable will be passed on to the command as parameters, which we declare in the file, like the resource group name, project name, username, and the public key. So for this command we need to specify this file and not the file from the internet. So let me change that. So we'll delete this section here, and instead of specifying the file from internet, we specify the file that we have currently here, that is ./vm.json. Rest all look fine. Now let's press enter. So we'll specify the resource group name, that is ARM-RG. Location will be Central India. Project name, let's keep it ARM. Administrator Azure user. Public key, I'll get the public key now. Paste the public key and press enter. Now let's wait for the VM to get created. Okay, so we have got the public IP of the VM that we created. Now let's check if the VM is working fine. Use the command ssh azure user add the IP. Type yes and press enter. So we have entered the VM, and we'll run the demo command that we ran previously to check everything is working fine. So with this we have deployed the VM using ARM templates. Now let's move on to the next demo. Okay, now let's move on to deploy the VM using Bicep file. So we'll create a file with the .bicep extension, so vm.bicep. So we first declare all the parameters that we need, that is a VM name, bicep-vm. We can also provide the description for the parameters. So we can also provide options for certain parameters, that is a type of authentication. So allowed is SSH public key and password. So I'll be using public key, so that the prompt will be asking me for the public IP to paste it. Next parameter is where we store the public key that we'll be pasting. So this is a DNS name for the public IP that we'll be using to access the virtual machine. So here we'll get an URL like structure instead of plain IPv4. So we get also options to decide for the VM image that will be used. For now I'll be using Ubuntu 22.04, and then we provide the location for the resource group, for all the resources, the size of the VM, name of the VNet, subnet, network security group, security type of the virtual machine, we'll let it be standard, and then the two images that were defined above, like Ubuntu 22.04 and 20.04, the extensive details are specified here, like which of the particular offer and which of the particular SKU to be used, and then we define the usual stuff, that is subnet, address prefix, where to store the SSH public key, and these are some extensions related to the security. I don't have any particular idea about how this works. If any of you know, you can put in the comment section. Next is we creating the network interface card. So as usual, private allocation method, public IP address ID, and then the rule to allow the SSH and the network security group. We create the virtual network with all the predefined resources. We give the settings for the public IP that will be created, and then we create the virtual machine with all the resources that we created earlier. We also enable some VM extensions that I don't have any complete idea of. And then we define 3 outputs where we get the admin username, public IP address, and the SSH command that will be used to login into the VM. So let's save and exit this file. To run this command, first we'll need to create a resource group. So we'll create the resource group using the following command, that is az group create -- name bicep -rg -- location central India. Now that the resource group is created, we'll deploy the resources using the vm.bicep file. So for that we use the following command. So we create a deployment group. So we use the following az deployment group create. So we provide the resource group parameter. So we'll change that resource group to the one that we created earlier, that is bicep -rg. We provide the template file. Since we created the template file as vm.bicep, we'll change that. And then parameters are admin user, that is Azure user. So let's press enter and wait for the other parameters to be asked. Now let's paste the SSH key. I could not paste the SSH key in this prompt for some reason, so I'll do one thing, pass that parameter in the command itself. So we have the parameters admin username, and then we'll use the other parameter, that is admin password or key equal to, let's provide that in double quotes. I'll specify the key and let's press enter. Okay, we can see that it has outputted the information so that the resources are created. Now let's find the SSH command. So here we can get the SSH command. Let's copy this and try to enter into the VM. Type yes and press enter. Now I can see we are inside the VM. So let's run the demo command as usual. So everything is working fine, and we can conclude that we have also deployed the VM using bicep file. Now let's move on to the next demo. Okay, now let's move on to deploying a VM using the Azure SDK. So I'll be using Python to implement this SDK. So let's create a file under the projects directory. We'll cd into the Azure directory. I'll create a file name vm.py. Before that, we need to create a separate directory so that we can install the requirements and keep the virtual environment separate for the Python SDK. Let's create a separate directory called SDK, cd into the directory. So I'll create the virtual environment here by using the command python3-m. M is for module. So we specify the VNV module, that is virtual environment, and we provide the directory where to create it. So I'll keep it under hidden directory name .vnv. Okay, so the VNV is created. Let's try to list it. You can see the VNV directory is present. So we'll activate the virtual environment by using the source command, and we provide the path, that is .vnv, under the bin directory and the activate file. So once we activate this, we'll get an indication that the VNV is activated. So we can see a indication besides the prompt. So now let's create a file named requirements.txt where it will contain all the modules that is needed to create the resources that we intend to create in Azure. So create a file named requirements.txt. So these are the modules that we need. So I'll save and exit this file. Now let's install the modules present in the requirements.txt file. For that, use the command python3-m pip install -r requirements.txt, or otherwise if you have the pip installed using the python3-pip package, you can do the following. So first let's check if the pip is present. Okay, so we have pip present in the virtual environment. So let's use pip install -r requirements.txt. Press enter. Okay, so the requirements are installed. Now let's create the file vm.py. So vm.py. I'll paste the contents of this file. Now let's understand what is done in this file. So we import the requirement classes from the module that we installed earlier, like default as a credential. This is the class that provides the methods to connect to Azure, like using the Azure CLI or the credentials file that we specified, or environment variables. This will be obviously used to create the compute resources, and this is related to network stuff, and this is related to resource groups. So we print a statement like provisioning a virtual machine. It's just for indication purposes. Next, we'll create a credential object using the default Azure credential class. So this will make sure that we get the credentials either from Azure CLI or the environment variables. Next, we need to define the subscription ID. This will be getting from the environment variable. So we have to make sure that we export the environment variable before running this file. Otherwise, we'll get an error. Next will be to provision a resource group. For that, we use the resource management client. We provide the credential that we created earlier, like in this step here, and the subscription ID so that we can create it. Next will be the variables, like what is the name of the resource group and where to create it. Next, we'll use these variables to create the resource group using this syntax. So this is created here. So this will be used to create the resource group. So we use the method of resource groups create or update, and we provide the details that we defined earlier, that is resource group name and location. Next we print that the resource group has been created. Next we define all the variables that we required further on, that is name of the VNet, subnet, IP name, IP config name, network interface card, and network security group, and the security rule name. So these are all the details that we have also seen earlier. Next we'll create a network client just like the resource client that we created earlier for creating the resource groups by providing the credential and the subscription ID. Next we'll create an object called Polar and wait for the virtual network to get created, and we'll provide the virtual network's begin, create or update method, and we'll provide all the resource details that we specified earlier, like the VNet name, usual stuff that we did earlier. And then we'll store the result in the VNet result, and we'll get the polar.result method, and the polar is specified here. Next we'll get the name of the virtual network that we created and the address prefix from this variable, so it will contain all the details. Out of that we'll get the name and the address prefix. Next will be to create the subnet just like the previous one. We'll get subnet's begin, create or update method. We'll store the results in a different variable, get the required details and print it. Next we create an IP address, same like the usual stuff like we did in the Ansible or the Terraform, and then we provision the network security group in the same manner. We also provide the rules that we need to include, that is allow SSH port, and then we create the network interface client with all the details that we created earlier. And then we lastly create the virtual machine by providing the VM name, username and the password. So we'll use the virtual machines begin, create or update, and then we provide the image details, hardware profiles like the VM size and the ID of the network interface client, and then we finally print the provision virtual machine, and here we'll print the VM result.name. Let's save and exit this file. Now that we have created the file, let's learn it using the command python 3 vm.py. Okay, so we forgot to export the environment variable, that is Azure subscription ID. So let's export Azure subscription ID equal to, once you exported, run the file again. Okay, so we see the first message, that is provisioning virtual machine. Next we'll getting the print statement like the resource group is created. Now let's wait for the VM to get created. Okay, so we have created the virtual machine. Now let's try to log in into the virtual machine by using the public IP here. So using SSH, now let's log in again. Azure user at IP, type yes and enter, type the password. We can log in into the VM. Let's run our demo command. We can see everything is working fine. With this we have finished the demo regarding deploying the VM using Azure SDK in Python. So this is it for this video. If you found this tutorial helpful, like the video and subscribe for more such videos. Thank you.